Hi, this is Dennis Spaeth, publisher of Cutting Tool Engineering magazine, and we're here at Iverson Company in Des Plaines, Illinois. And we're here to take a look at another Camp Champ that is today hosting the Chippewa Middle School in Des Plaines, just down the block, with mentors from Taft High School, also not far away from here. So let's go inside and see how things are going. So this is the first of two camps that are taking place here today, and the Chippewa Middle School students have been here since about 9 o'clock, and there are several stations set up that they go timed intervals. They switch from one station to the next, but they learn about different aspects of what it takes to manufacture, in this particular case, pens, that Terry Iverson has supplied all this wood that has to be turned on the lathe and milled on the CNC mill that's over here. What I would like to do real quick is just show you all the different stations.
So we'll start in Station 1. This particular camp is our 11th and 12th camp overall, and our 5th and 6th camp for 2024. We did also, in addition to that, we were down at IMTS for 6 days. We went to the MFG meeting for AMT for 3 days in March, and we also went to PAC Expo for a day downtown in Chicago in September. But just to kind of take you through each station, the first station, Station 1 is over here, is inspection. So what's important to teach young people, we want to teach basic inspection, and what's important is to understand the math. A lot of young people and even a lot of grown adults don't necessarily get down to this degree of detail, or they learned it so long ago they don't recall it. But we want to teach them the difference between an inch and, of course, a tenth of an inch, which is 100 thousandths, and then a tenth of that is 10 thousandths, and a tenth of that is 1 thousandth, and a tenth of that is 1 10,000th. So in the industry, 1/10 means 1 10,000th, not 1/10 of an inch. A human hair is about 7 thousandths in diameter, just to put it in comparison. And we, in our industry, we sell and service machines that go down into 10 millionths resolution, which is 1/10 of 1 10,000th, just to put it in perspective. But we're using calipers and mics, and young people are getting a good appreciation of the finer art of inspection. So Station 2 will be, we'll go over here, it's the lathe. We make a pen out of wood. The only reason we make it out of wood is we can sand it and stain it, and we don't have to run coolant. So we could make it out of metal, we could make it out of any plastic, but wood's the most forgiving, other than the sawdust. On the milling machine, we do capture the sawdust with a vacuum. On the lathe, which you can probably hear behind me, the lathe, we actually have to vacuum it out periodically, because it's not quite as detrimental to the operation of the lathe as on the milling machine. So here we have Station 2. Station 2 is the lathe. These are the wooden blanks that we actually make the pen out of. We have a top and a bottom. So it takes 2 pieces to make a complete pen. These are our middle school students that are actively participating in making the pens. You have a CNC lathe that's driven by a computer. We're using what we call Mach 3 software, which is a offline system that has G-code programming. And then, of course, on the lathe, you're going to have the part spinning, and the tool is traversing both in diameter and length to actually make the component. One of the things on each station, we have a placard that has in English, Spanish, and Polish what that station is. For example, this one is CNC lathe, which is in 3 different languages portrayed. These are the 2 segments, or 2 of the segments. This is the bottom segment of the pen, so you'd hold the pen like this. And then this is the top segment, which of course would be in this, like in this case, and then the actual ink component will be in the middle. You'll have a clip on the top, and then of course you'll have a tapered end piece, and then you have a twisting segment in the middle as well. So those are the parts of the pen. So now we're going to go over to station 3, which is over here. After you make the pens, then you want to sand and stain the pens. After you turn the pens, they come over here and they need to be sanded and stained. Here's a finished pen, and you can see it's been sanded and stained, and you'll see the assembly of it at the next station actually. So what we're using is we use a programmable indexing head to rotate the part so they can evenly sand and stain the actual top and the bottom of the pen. And so it gives them a chance to get more hands-on, and then Jesus has the opportunity to learn how to program it. He can speed up the index, he can slow down the index, and he can have it indexed in different increments as part of his presentation to the young people. So that's station 3. So we're going to go to station 4 behind you now. Okay, station 4 is going to be assembly. So we have a couple assembly presses. All right, so here we are at assembly, and we have the top of the pen. The top of the pen is pretty basic in terms of what needs to be assembled. So you have a clip that goes on the top, and then you have a segment or a small turn component that goes in the top. So this press over here will actually allow us to bring this down and literally press that in, and I won't press it in right now, so I'll let a young person do that. But that's how the top is assembled. The bottom is a different story. You have a twisting segment that allows you to twist the actual pen itself, the pen segment, up and down inside the actual bottom part of the pen. So what we have to do is we have to insert this, the twisting segment member, into the base of the pen. So that's what this is here.
Right. It's okay. It's okay.
So what we do is we have a spring-loaded press, horizontal press, and I'm not going to press this in, but this is how we do it. And you have this stop so that we bring this lever back down, the brass piece will go in and slip fit into the barrel of the bottom of the pen. Then when we're done with that, we actually mount this and we bring the cone, which is the end of the pen, hold it in a fixture, and then we bring it down in such a way that we press it down into the barrel of the pen, the base of the pen. And then after we're done with that, all that's left at that point is to insert the actual barrel of the pen with the ink, thread that into the twisting member, and then put the spacer on so that the top of the pen can go on. And the top will actually go on after it's assembled. It'll be pressed on like so, and then voila, you have a fully assembled pen. So that's station 4. Station 5 is the CNC mill. Hey, going to explain a little bit about the CNC mill real quick. So the CNC mill, I'll borrow your gift. What we're demonstrating on the CNC mill is that we can make cases out of wood. Unfortunately, to make a case, you have a top and a bottom, and you have 15 minutes of machining on each side to give you a full case. So it's not really effective to machine for an hour when you want to give out 48 to 56 pen assemblies. So we use a cardboard box, and we actually put the pen in a cardboard box. Here's our finished pen that Roan has. This is Roan's. And then it goes in the cardboard box, and then the next station will show you the laser engraving. But the CNC mill basically uses an end mill. This is a roughing end mill, and it has a three-axis motions. The part has X and Y, and then the tool has Z. So this allows you to mill out a large area with a roughing end mill, and then a finishing end mill will allow you to, in this particular case with a flat bottom end mill, we can actually carve out the actual assembly so that we can just punch it out when it's all said and done. Because we hold 2 pens in the wooden case, we have a ball nose end mill that can actually route out or mill out where the two pens actually reside. So that's the CNC mill. Behind us, we have a Bridgeport CNC machining center, which actually has a pallet changer, which actually can change out 2 different setups automatically. And that's one of our partners, which is Bridgeport, one of the icon machine tools of our country and industry. So that's station 5. So now we're going to go to station 6, which will be the laser engraving.
Hi, how are you? How are you like?
Okay, so here we are at the laser engraving station, which is station 6, I believe, yes. And so what we're going to do is we're going to show you how the laser engraving process works. All right, so after this is completed, we have to make sure that the plastic is off of the actual aluminum plate because they coat it with plastic. And then the first thing you have to do is you have to put in the software, which I believe is called Lightburn. You can put in the name of the individual or the organization or the school into the template, so to speak. In this particular case, this is Chippewa Middle School, so we have their logo on here. So what we have to do is we have a fixture set up so that we can have the plate reasonably straight, and so that the actual laser engraving is fairly parallel and straight. And the first thing we have to do is we have to home out the actual laser head so it knows where it's starting from. And then what I'll do is, after I hit start, you can get a close-up and you actually can see the whole laser process. It probably takes about 2 minutes. And then because it's burnt, it's burning, off the these are anodized aluminum. So it's basically burning off the anodized black, so you gotta actually wipe it off.
We're here now with Alicia Kepke, teacher at Chippewa Middle School, just down the road. It's in Des Plaines.
4-minute drive.
So this is a short commute to bring 2 sets of students from the middle school here today for 2 different camps. And we just got the second camps going here this afternoon. But what I want to ask you about is your interest in this program, because this isn't just the second one you've been part of. You did this last year, and
Yes.
so I'm kind of interested in hearing about what it was like last year, what you think of a program like this for middle schoolers, and what they got out of it so far. You can share your experience from last year and so far this year.
So I am a middle school STEM teacher, and this field trip is a great hands-on experience to open up the kids to science, technology, engineering, and math to make sure that they are doing those precise measurements to make sure that making a pen actually works. So it brings together all the subject matter that I teach, getting students out and getting them to do anything hands-on in the community, gets them more involved and more interested in careers in this type, opens them up to fields that they may have never seen or have never been exposed of before. I did it last year, and students loved it so much they were eager to go home and show their parents, I made this, I played with all the CNC machines and I got this to work. So I've been in contact with Terry for quite a long time, and he has come to our STEAM nights at school as well. He's become a good friend of mine, and it's nice to get the students out and learning in a hands-on experience.
You seem pretty well versed in STEM, STEAM, and the rest of it. What drew you to this particular part of teaching? And when did you get interested in going this STEM route?
So I started with my degree in math, actually, and I taught math for 7 years. When Common Core came out, I did not want to teach students one way to solve a problem. I think that if a student can show their work and use all the skills they have to put together and get to the answer, I think that's okay. So I ended up getting my master's degree in educational technology so that I can go the STEM route. I love how STEM is always changing. It's always improving. Every year is different. My class from quarter to quarter changes constantly. I'm always adding new things, trying to make it more hands-on, getting the kids together to do teamwork and collaborate with each other, because that's a skill they need in their business world as well.
Yeah, problem solving, it's critical. The fact that you are bringing this to middle school, was that a game plan of yours, or how did you make this happen? Is this a role that you created?
Actually, Terry reached out to us at Chippewa, being so close, last year and asked if we wanted to partake in this opportunity. He said the Maine West kids were involved last year. So being that those are role models for the kids, it's where the kids are going to high school next. It was nice to have those kids as the role models last year, and then having the Taft students here this year as well. It's just nice for them to work with older students and see like you're progressing to this age level. I also do a robotics club at school, and a lot of my students in this room right now are a part of robotics club, so it's once again getting that teamwork and collaboration and just keeping those open relationships with the community.
How long has the middle school had a robotics club and a STEM program?
I have been there for 8 years now, and when I first started, I got hired on as a STEM teacher, but we changed it from informational technology to STEM. So during my years, we changed that. We also adopted new curriculum, so we do more design and modeling and engineering design process within the curriculum.
What does that involve? I mean, when you're in the curriculum, is it largely book reading and classroom?
It is all hands-on. We give the kids materials, we give them a challenge, and we say, okay, here's the challenge. You got to work with your team, come up with a plan, bring the materials together. We give them time limits, so they're going through the constraints of limited materials and limited time, so they're thinking like engineers and seeing, if their product and their prototypes are going to work in the end.
What kind of machinery do you have?
We actually do not have any machinery. We make prototypes out of cardboard. I am a junk collector. All the teachers know I want paper towels and toilet paper rolls and tape and scissors and paper, and they make things work from just simple materials. So we just start basic. We do have 3D printers, so we do try and print some things from time to time and see if it will work with what their innovations are, but we just keep it simple until they get to the high school level. I'm just trying to spark their interest really in middle school.
So you're getting their interest going, and then they get to come to a program like this and actually make something. Does this connect the dots for them? Does this give tangible?
They really get to see the engineering process come to life. They're used to getting, their engineering plan. They got to do their blueprints and then gather materials and make something and test it out, and then we don't really get to the improved stage as much because we have such limited materials. So coming and being able to actually use the machines really brings it to life for them to see, oh, this is maybe a career path I would really enjoy getting into.
And career paths aside for just a minute, how excited are the kids from your perspective? Just you've seen a number of kids come through the program. When they first experience this, and maybe afterward, kind of give me some idea of what they've told you.
2 weeks ago, I gave the permission slip, and they have come to me every day. Are we going today? Are we going today? So they are very excited to be here. The first session, when we got back to school, they were already showing all their friends, look what we made, look what we made. So it's really cool because then they go home and I get the parent emails, and the parents are like, can we get some pictures? What did they do? Where were they? They want to go back. So they really do enjoy the hands-on, and they like spreading the word to their friends and their families.
So this is kind of off topic a bit, but when they first pull up in the bus, are they unimpressed when they first get out and see the outside of the building and this just displays? I mean,
Yeah.
I mean, but once they come in here, it's like it doesn't matter what is going on outside.
No, not at all.
And there are buildings like this everywhere. Do you deal with that invisibility of this industry at all with the middle school kids?
Yes, so it's really hard to get outside companies to want to come engage with middle schoolers. I always try to get volunteers to come in, and manufacturing especially, they're so busy with their day-to-day jobs that a lot of times they don't have the time. And they have to get deadlines done or whatever. So when the kids come up and they're like, where are we? What are we doing? They get a little worried, but as soon as they walk through the door, they're looking at all the machines, wondering, what do these things do? So it's a cool opportunity then to learn machines that they would never see if they didn't have this field trip.
You like the pen process.
I do.
And pick up on it. Terry said I should ask you specifically about someone from last year's program recently came up to you.
Yes, so I had some special needs students join us last year who had the opportunity to come, and he saw himself on the website. And he said that Champion Now website, he saw that he was on there, and he was like, I'm famous, Miss Kepke, I'm famous. And some students have even asked to see Mr. Iverson's book, and they've checked it out from me, and they bring it home, they read the student and parent version. They're more interested now in the manufacturing field where they may have never been exposed to it before.
So now I want to ask you, you've got a unique perspective. You said a master's, right? Mm-hmm. So you understand the value of a college degree, and there is great value in having a college degree. However, how important is it for students beginning maybe at this age specifically and all the way up to first learn and know there are alternatives that may not involve even a 4-year college degree?
It's very important, especially with how diverse our school is. We have a lot of students that are lower level income and don't have as many opportunities as other students. We have students that drive in on taxis, that are homeless and live in hotels and just don't have the funding in their families. So being able to see that I can still be successful even if my family doesn't have money is really important. You know, they could still get other careers that don't involve being in a schooling.
And just having another option other than going and working at JCPenney, if it still exists. Sears. But so other options.
Venture.
Yeah, I mean, for a lot of us my age, it was college. Everyone was being told to college, and to some extent, I think that's still the message. The expectation seems to still be go to college, when it could be
go start working, make some money.
Working in this industry, and if you really like it, you may decide you want to become an engineer, and then maybe go into, or you might just end up liking it because it's going to pay well. You can make a whole career out of this, and make good money. So, I think what I am kind of interested in finding out now is what can anyone looking at this and learning about it and hearing about your specific situation, I'm like this industry or someone even not in the industry, help your program and awareness of the program in any way? I mean, do you need some outside help?
I think it's always great when outside people in the community that are already engineering, manufacturing, anything, come in and show the kids how real it is. Because they can watch videos on YouTube, they can do different activities in school, but they're learning from their teacher. When they learn from a professional, or when they even see anything hands-on from professionals, they're more engaged and eager to know more and ask questions because they know that person is an expert in that area. So I've had pilots come to my room with my flight and space program. I had a Google software engineer come and visit for Computer Science Education Week this week, and the behavior of the students and their engagement is spectacular, and just seeing them with their like surprised faces when a volunteer is there gets them really excited about the learning even more, because they don't know what opportunities they have until they are exposed to them.
So, anyone that specifically share with us who visited your school?
So yesterday I had Fletcher Oliver, who's the Google software engineer, who came. I also have had Sean Bowden, who's a captain for American Airlines. Last year I had a couple different engineers from code.org they sent us. Argonne laboratory scientists have visited as well. So anytime I have the opportunity to reach out and get more guests in, I take it right away. And I even email out to all the parents. Do you know an engineer or anyone in this field that would be interested in coming and talking to the students about their careers? It just helps the learning come to life.
So what would you say to anyone else out there who's wondering about the effectiveness of Camp Champ? Anything that, not that, I'm just wondering what you would say to anyone out there thinking about getting hooked up with something like this.
Definitely. Camp Champ is an excellent opportunity for students to come and hands-on learn the engineering and manufacturing process, being able to work with a group, collaborate, and bring the learning of manufacturing to life.
Yeah, I'm kind of amazed that you have such a passion for this message. Where did it come from?
I've always really been engaged with problem solving. Teaching, I think that's an incredible skill that everybody needs to have. I feel like during COVID, a lot of students lost that with not being able to be with their peers. Teaching online was the most difficult part of my career, because I'm always getting kids together to try and teach them teamwork and how to problem solve together. Put your heads together to figure out what solutions there are. And everyone comes up with different ideas, so especially bringing different diverse people together, they come up with all different ideas. I tell them the craziest ideas are the best ideas. It's a skill that you need for the rest of your life. Even if you get in an argument with a friend or a parent, like, you use the engineering design process to solve your problems, whether you realize it or not.
Thank you so much. I appreciate you taking the time, and I know you're going around and keeping an eye on the kids as they go through their stations.
Yeah. I love seeing their faces and their expressions with what they're doing.
Thanks a lot.
Thank you very much.
Hey, first name?
Tony Schmidt.
And you're
I'm a teacher at Taft High School. I teach physics and intro to robotics now. And I also, a big part of what they're all here for is that I also coach an after-school FRC program, first robotics competition. So we work to machine and build what can be a 150-pound robot that can be upwards of 6 feet tall. So every kid that I brought here today is a participant in that program after school.
Perfect. That's going to be the start, okay? So thanks for agreeing to be on camera here.
Yeah.
So we're just wondering about the reaction from the high school students being mentors, and that's your role here today from Taft High School.
Yeah.
What did it take to get them to volunteer to come in and do this today? Are they?
So First robotics is a huge amount of work, and so pretty much I have cultivated a group of students that have pretty much, when I'm like, hey, do you want to go do this thing, they trust that like it's going to be exciting and they're going to learn new experiences. So it has taken a long time to get to the point where I can offer opportunities that they know are going to be engaging, and they kind of just go. We went to IMTS, the convention, earlier this year, and we were able to see this in the convention space, and they were like, how do we get to do this? How do we get to like go and be a part of this? And so I was able to bring this group because they were excited about it, they saw the opportunity, and I really want it for them because it's one thing to know it themselves, kind of, because there's high schoolers, they're still learning. It's a whole different thing to have that conversation with a bunch of middle schoolers and be like, this is why I'm excited about it, and sharing that with them.
Okay. And so that you didn't have any problem getting them to show up here today. How much time did it take them to train on each of these stations before they were able to take over?
So they took over as we walked in this morning. Most of them, but it's building on the same tools and expectations that we build in the FRC program, and every single one of them has been on the team for the past 2 years, at least for the past 2 years.
FRC, can you just...
Yeah, so First Robotics Competition is their after-school program, and so the First Robotics Competition is a huge amount of time. They're putting in 20 hours a week on top of everything else, and so they're learning a lot of these skills, and so I kind of placed some of the students in the areas in which they were their strong suits. And so, for example, Desmond, he came in with some awesome skills, and so I was able to put him with inspection so he could start talking about the realization.
I was just going to say, did a little tour to open this report up, and as we're going around, I heard him explaining the caliper, and he's got a very good approach. He's very good at teaching. I could hear it, and we were just kind of listening in for that for a brief period of time.
Yeah.
So, nice group of kids.
Yeah.
So is this, in terms of manufacturing, as an industry that offers careers as an option, I'm really interested in hearing your thoughts on where that is on high school, at a high school student level. Where is it on their radar in terms of careers?
So one of the biggest challenges with manufacturing as an option is the fact that it's not the option that gets put in front of them most of the time. There's a lot of money and effort that gets for them to see college as an option, for them to even just start working. So like it's really hard to convince them of what else is out there because it's not given the same flashy front of mind, right? Like they have college people that come in all of the time and offer these products and things that they can do, and they never get to see all these other invisible things that exist all around them. They could have driven past Iverson every single day, and we at Taft, we are lined with probably a dozen old manufacturing companies that have been there forever and like very similar to Iverson, and they pass by these buildings every single day and have no idea what goes on inside of them. And my biggest challenge is how to get more introduction to that and how to bring it in a way. And the kind of tricky part is that the people that could come talk to them are the people that do manufacturing tend to be older. And so like if you're a 16, 17, 18-year-old kid, it's hard to hear that 50-year-old guy that comes in and talks to you about this manufacturing opportunity, and for you to see that as a real option for you, which is really nice that they're able to talk to this group as high schoolers to middle schoolers because they have a much closer interaction with them. But I would love to see manufacturing be able to actually share the passion for what opportunities exist in a way that students can achieve. And I don't know, I hope that what I'm doing is part of that, but it is tricky to get them to see it as an option because it's not the flashiest thing in the world.
So in convincing the students is one part of it, right? That to get them interested. The other part that Terry has been working on with this whole champion now is to get parents and not just parents, but the rest of us, adults in the world, to
the whole village, right?
To reconsider like manufacturing as a legitimate option. It's not what it was.
Sure.
So growing up, curious, what did you think about manufacturing, and how did you first start getting interested in this?
So I didn't really have a career path. I found in my science class my sophomore year in high school that I was really good at teaching. I taught my whole table, and like it became an option of like, oh, I could actually do this. When I graduated college with my chemistry with an education certificate to teach, I didn't find a job right away. I needed to teach in Chicago for a scholarship, and I didn't find a job right away. And so my first year out of college, I actually worked at Avon Cosmetics. I worked in their manufacturing floor, so I worked in quality control. And so I was interacting with processors, I was interacting with the line, and I was an integral part of that manufacturing process. So I really got to see firsthand, and that took me into realizing that like how big this somewhat invisible industry is to students, and the fact that it's not just they're not just being forced to sit in a line and put things in. That exists for some places, but it's going away in a lot of ways. Companies are trying to pull that labor out, but there doesn't mean that labor is going away. You have people that are specialists in getting manufacturing lines to run and are flying all over the country to work on machines. And like, I see my creative students that could be solving creative problems every single day by finding a skill and becoming really good at it, and we will constantly need those people. And so the students that I'm bringing here today, I want them to see this as an option, because one, it can challenge them in ways they don't realize, and there's also going to be room for them to grow in that industry.
Right. I mean, there's a couple of things I want to touch on here. One is you keep mentioning invisible, but I want to talk about also the challenges that are presented day to day in any kind of shop around the world, really. When it comes to machining and metal cutting, there's all sorts of challenges that pop up, and you need to problem solve to figure out. So this isn't just assembly line kind of manufacturing factory kind of thing anymore. And this is much more intricate, much more computer oriented, and you have to know the best way to cut the metal. As much as they're learning here today about cutting wood, there are tools and machines that cut metal just as easily as these machines are cutting wood, and that is a sight to behold.
Yeah.
And I just wanted to cover that. I don't think there's a question there, but
no,
is that a point that gets across, and are they kind of seeing that?
So I imagine that they're seeing it here, but my students, we machine all of our parts in house.
Oh, wow.
So we use mostly CNC routers. But we have 2 metal cutting CNCs. We have larger form laser cutters that can do more wood. So we're doing MDF board that we're cutting to prototype, and then we're taking it over and we're cutting aluminum. So we have metal cutting bandsaws. We have miter saws that we're using to cut aluminum extrusion. So all of our parts are drilled, programmed, and built in metal. So when you're building out something that's going to be 120 pounds, it can't be wood or plastic. Like it moves into that next category of needing that strength. And so I know my students can see that. And I was giving grief to one of my students that came here today. He's like, well, I'm not so big on the CAD stuff, but I like the fabrication side of it. I was like, that's great, but like you are going to need to interact with, like, it depends on what role you want. To solve more creative problems, you're going to need those skills. And maybe you're not doing CAD every single day behind a computer, but you're going to be working with machines, and you need to know how they work and what their thinking process is to do that. And so I'm really just trying to give them an opportunity, because even if they go on to be engineering, even if they don't go into manufacturing directly and they want to be behind a desk, they should also be able to know how to make things, because a lot of them, it's like, go grab the hex. It's like, well, I don't know what the hex is, and so like I want my mechanical engineers that graduate from my program to know how to build something. So when they talk to somebody on the line that's like, I've been doing this for 20 years, they're going to be like, I understand. I know how hard it is to actually make things.
Yeah, that's one of the common complaints on the shop floor, is that the engineers are disconnected from the real practical world of machining. And that's not, I mean, that's the generality, but there is some of that out in the industry still, and they're still trying to, there's a whole program going on in Utah where I think it's Sam Schiller is starting a program to kind of get engineers more involved on the shop floor and making things. So that's a push. But can I just go back to, you've mentioned a couple of times, the students, a lot of the existence of manufacturing in our communities is invisible. I want to find out kind of why do you keep saying that? I mean, what aspect of the industry is invisible to them? As consumers, they interact with the product, they get the product, they don't, and so much of that product that exists in their hand is assembled in one place and moved across the world, and these things are all happening around them, but they don't know it. They don't know that right behind their school there's a laser cutting place that does large form laser cutting, that laser cuts metal and does custom parts. They don't know necessarily that one of our other partners does injection molding right down the street. They don't, because they just get the thing.
They don't think necessarily, not all of them, some of them do, but they don't think about how did this thing get in my hand. I go and buy a thing, so few of them have ever made a thing, and so they don't think about the process of what it took to actually get there. They know I got money, I go buy a thing, and I consume it. And so few of them have created a thing themselves beyond,
Yeah, so, I mean, it can be fun and eye-opening for someone to learn that the plane they're flying in, maybe, or the car they're driving in, one small component may have been made just down the block from where they live.
Yeah.
And then it goes off to another shop, or goes to the original equipment manufacturer, whatever it is that they experience. So that I know it's an eye-opening experience for anybody who has been unaware of the existence of manufacturing in this country. It's not like it doesn't exist and it's completely gone away. It's never completely gone away.
No.
We have all maybe forgotten about it, but it's not gone away. And now it's starting to kind of pick up interest again. And for good reason. It provides a good career and a good livelihood. What do you tell your high school students about potential careers? Do you have any kind of a discussion like that with them?
I certainly have a conversation with, so I always enter into any conversation with, I take how much time it's going to take them to graduate, and I ask them what are they going to be doing in 2 years, 3 years, 4 years. I don't ask them what college they're going to. I don't ask them what they're going to do for work. I ask them what are they going to be doing. If I talk to you in 3 years from now, what are you doing? To try and open up this conversation that it's not just about, it has less to do about where you go and more about what you're trying to accomplish. And that drives the conversation. Oh, I want to be a teacher. It's like, okay, then your path is college, and these are the colleges that are good at that. It's not something that's super important. You don't need to go to the most expensive college in the world. There's community college, or a student's like, I want to make things. Like, I don't know that, and then it's okay. Then these are the programs. Maybe you go to TMA and you go through an apprenticeship program. Technology and Manufacturing Association here. They partner with a bunch of schools. They partner with a bunch of companies, and then they work on apprenticeship programs for people that come in, and they host classes and things like that. Maybe Desmond, for example, wants to go directly into the workforce and then start a trade in doing being an electrician. And then
my daughter just finished Lincoln Tech. She just graduated.
Awesome. Yeah. So I really try to make every effort to let them drive the conversation about what they want to do rather than what they've been told that they need to do to make that happen. And remind them that there are industry partners all around us that still make things, and there are jobs that you can have that aren't bad, that you don't just have to be working at the retail store down the street to actually have a really good job.
With benefits full time, and we're talking about problem solving. A problem-solving career, because a lot of days you're going to go in and you're going to have to problem solve when something happens, like tool breaks and you're not sure why it keeps breaking.
Yeah,
there's something wrong, so they do have to problem solve. So there's
you're okay.
I mean, the college thing, it's not an either or. I mean, the other thing that I like to remind people about is, if you're not sure what you want to do and you are somewhat interested in building things or making stuff with your hands, this is a good option to go straight into, because it's not going to really cost you anything to get into this industry. It'd be good to get some training. A lot of times a company will hire you and train you as long as you're going to stick around.
Yeah.
But down the road, you might decide, like you mentioned, you might want to learn more about engineering after 2, 3, 4, 5 years. A lot of times these companies will help pay for that engineering degree that you might want to go and get from a university. But to just blindly go to a college thinking you're going to discover what you want to do, which happens for some of us, but it is maybe not the best road for everybody. And it's not an either or. I mean, this is just an option And I think that's the biggest message that I like to get across to people when we share this story about Camp Champ. But I just want to thank you for taking this much time to talk to us.
Yeah.
I really appreciate it. And I think we have to get over to Taft, and maybe, since you're so close, we should do something.
Yeah, that'd be great. Thank you so much.
Thanks.
I appreciate you.
Everybody say cheese.
Everybody say manufacturing rocks.
Manufacturing rocks. What? Nice. Camp Champ.
So here now with Terry Iverson, who's the founder of Champion Now and the Camp Champ program. And Terry, thanks for the T-shirt.
Yeah, you're welcome.
This is the T-shirt that was given out today, and T-shirts like this are given out at each of the camps that Terry does. And I want to just kind of conclude the report today asking Terry, now that you've done at least a dozen of these.
Yeah, this is our 12th camp, actually.
How are they going, and what have you learned, and give me an idea of how you think this has progressed.
Well, I tell you, I'm always fascinated with some of the young mentors that are from high school and some of the value that they bring to the middle school kids. But every camp we learn something, and it may be a big tweak that we make to the camp or just a small tweak. But by having the recipe and continuing and being consistent, doing the same thing, it makes it real easy to make little, tweaks along the way to make it the best it can be. I'm trying to think some of the, I've changed some of the shirt designs. We went to short sleeve shirts for the young people and long sleeve shirts for the sponsors and partners and the high school partners.
You have a sponsor here, and on the back of the shirt you have.
Well, this is the front. You have Camp Champ, you have Taft High School and Chippewa Middle School, and then IMEC has been generous to sponsor both last year and this year to give us money for the carrying costs. Just the shirts alone are a pretty heavy investment. But in particular, we have Iverson Chucking Machine, CDI, and custom products. The Iverson legacy started in manufacturing 100 years ago with my grandfather. And the tie-in with this camp is that the high school mentors are from Taft High School. And my two uncles and my dad went to high school at Taft High School. So that's the correlation. So I wanted to make sure all four logos were on this shirt. Then Liberty Machinery, Forster Tool and Manufacturing, and then Gray Machinery, CNC Exchange, they also sponsored the last two camps as well.
It's worth sharing that with everyone because every sponsorship that you get, every little bit of money helps.
It does.
Keep the program going, and you're always looking for more help, and you're also trying to still expand this to other areas in the country.
Yeah.
I don't know how those you want to update us where that's at.
Well, what I try to do is provide a turnkey camp. So many people believe, like I believe and like Dennis believes, but they don't know how to go about something like this. So what we try to do, we're standing in front of crates, that the 3 crates actually house the entire camp. So the CNC lathe, the CNC mill, the laser engraver, the CNC indexer, all the assembly presses, all the inspection equipment is all housed in each crate, or I should say the 3 crates collectively. So we can ship a camp anywhere in the country, and then basically they can have their own manufacturing day 200 days a year. So the camp itself, the kit is about a $50,000 investment, and we can rent it out, we can lease it out, or we can sell the whole kit. What I try to make a case for is either an association or a consortium or a large corporation that has either a lot of vendors or a lot of subsidiaries. They can actually buy a kit for the camp and then send it either once a week or twice a week to all these different locations, and they can have a manufacturing community event that can start the pipeline of new employees for decades to come. Manufacturing Day is a great event, and some states do Manufacturing Month, but our industry needs more than that. So this is basically a Manufacturing Day kit that people can do Manufacturing Day type events all throughout the year based on where they want it to be and to reach maybe the segment of the population that doesn't know anything about manufacturing.
And the big key there is bringing a hands-on learning experience to middle schoolers and a chance for high schoolers to be mentors. So it seems like they're getting smoother and smoother. And, just curious if you're 2025, how that's shaping up for more of these camps.
Well, I think, we'll see if IMEC wants to do a third round going into 2025. But I do challenge, the industry as a whole to either consider giving to, Champion Now as an organization, or possibly look at how you could fund either regionally or locally a camp, whether it's leasing the camp for a period of time or buying a kit. But I know there's like-minded people throughout the country, and I know a lot of people, once they learn all the nuances of not only the middle school kids, of inspiring them into manufacturing, but also the high school young people and the mentoring component of it. A lot of people think that our future CTE instructors are going to come from a program like this. And that's something initially I had never really even thought about. But I think that, I think just exposing more people in this country about manufacturing and taking the event to where people that don't have access to it, I think that's one of the critical components to make it as portable and as turnkey as possible. I think that has a big impact, or will have a big impact.
Well, this has been a great day for me to visit. Impressed by the mentors and the middle schoolers. It's been a great program.